can also, now that we have this decentralized network that reaches consensus about order of transactions, we can actually deploy code pieces into this blockchain, which are digitally signed and timestamped, and this code is actually executed as part of the transaction validation process. This process is called smart contract. So you deploy a piece of code into the blockchain as a transaction. Then this piece of code runs inside the nodes in the blockchain. You trigger it by sending it other transactions or other conditions like the generation of a new blocks. There are many, many variations of this. Today I'm going to show you our solution, which is very unique. It's of course developed in Java. It runs in a standard JVM, so you can develop it with any Java IDE that you like, debug it, unit test it, and so on. And I will show you. How it works. To deploy a contract into the Ardor blockchain, you develop your contract as a Java class file, package it, we package it for you automatically into a jar file, and we just store it as a byte array in the blockchain. When we want to trigger this contract, we implemented a custom class loader, which loads these bytes, rebuilds the jar file, unzip it into class files, and executes the main class of the contract. Whoever runs the contract runs it inside a security sandbox, so that the contract cannot harm the workstation that actually runs it. For example, it cannot access a local disk or do all kind of damage. Okay? We have, in the blockchain world, you have to understand that because it's so decentralized, it's also a magnet for people that try to cheat and scam and so on. So we have a verification mechanism to tell you that if someone gave you some source code and tells you that this contract represents this source code, we also have a mechanism to make sure that a certain source code is actually that a certain contract is actually built out of certain source file. So there is no manipulation. Let's look at a very simple code example. As always, let's start with hello world. Okay, so hello world contract. See, a contract is simply a Java class. It extends abstract contract. It implements some kind of callback. If you ever programmed a servlet, do get, do post, it's very similar. You get a callback when a transaction is processed. You get a transaction context object, which is basically the bridge between your contract and the blockchain. So you can see you load the transactions that triggered the contract. And in this case, what we want to do, we want to get someone sends the contract a message. We want the contract to send back hello to whoever sent this message. So we basically build a JSON object, create a send message transaction, and submit it to the blockchain. Okay, nothing too interesting, but bear in mind this is all certain plain Java code that you package and deploy to the blockchain, and whenever someone triggers it with a transaction, it answers with a message back. Really not that interesting. Okay, so let me try to show you something more interesting we can do. So in the blockchain world, the guys in the blockchain world are very fond of Twitter. Okay, we want to do everything publicly, broadcast all over the world, build a community, get people to follow us so we can send our message, we can deliver our message. And this actually can worth some money, okay, it's for us. So we want to encourage people to actually join and follow our Twitter accounts, okay? Normally we cannot, I mean, we're not going to pay them money for this, but how about we create a contract that pays some token to whoever follows the Twitter accounts that we want them to follow, and we can broadcast messages to them, and it's also easier for them to create new accounts. So what I want to show you is how we tie a Twitter account to a blockchain account and automatically fund this blockchain account if it actually does what we, the conditions that we define. So our condition for, this is a new Twitter account that we ask that it will follow the three main Twitter accounts used by Jelurida. This is a company account. Ardor is what we call the parent chain. Ignis is what we call the first child chain. We want people to follow it, and we are willing to pay some tokens for it. So the process works like this. The user will need to to create a new account. Okay, so when you create a new account, we generate for you these 12 words. Okay, these are very important. This is the account seed. The blockchain world is not forgiving. If you bought some tokens, you have some tokens in your account, and you forget the seed, these tokens are lost forever. Okay, and it happens quite a lot. So you have to be very careful when you deal with a blockchain. If you expose it in a conference, for example, and someone steals it, they control your funds. There is no bank that you can call to reset your account or something. You own your tokens, and so you need to be responsible for it. So for this demo, let me copy the new account. This is a new account. We call it passphrase, and this is going to be my new public address. So let's keep it here. We'll reuse it later. For now, I needed to make sure that we make sure that you actually remember it. And I'm going to prove now that I own this account to Twitter. Okay, how do I do that? What I do is I generate a token. A token is basically a signed piece of code. And the piece of code I'm going to sign is my Twitter handle. Okay? For some reason, I'm taking this piece of, this is a unique Twitter handle. Okay? If I sign this unique Twitter handle to generate this thing, it proves that I own this account. Now to tie it to the Twitter handle, I will go to Twitter and simply tweet this data. Okay, so this is a setup. I created a new account on the blockchain, a new Twitter handle that follows some condition, and I link them together in both directions. Okay, when I check Twitter, I can see that someone was actually someone signed something on the blockchain account. When I look at on the blockchain, I still don't see anything. So what I'm going to do now, I'm going to trigger, let me see, I'm going to trigger the contract and tell it that I want to fund this new account that I created. So I'm sending a request to the contract runner account to activate the Twitter follower reward contract that we'll see later, okay? And I'm telling it, please fund this Twitter handle. Where am I? I think I'm here. Okay. Right, now I need to sign this transaction. This is okay. Now the contract should do its magic. Okay, the contract will be activated in the next block, and it will send some funds to my new account. The demos of blockchain are always a bit problematic because you never know when the next block is going to be generated. Okay, so while this happens, it should happen pretty quickly, but okay, let's just see. Sometimes we have. Sometimes we need to help it a little bit because we are running here on a public testnet. Is it transaction? Wait. So it's just a second. Okay, so you see what now I'm looking at the account that actually runs the contract. So you see it received a message. This is a message I sent. It's encrypted, and then it sent back an ordinary payment to the account that we created. If we look at the wallet of the account, we can see that it now has that it now received the transaction. And then, as I told you, whenever you try to do this type of promotions, people will try to cheat you. What they will do, they will create a single Twitter handle and then try to fund multiple accounts. Or they will create a single account and try to create multiple Twitter handles. So whenever we operate with blockchain, we always need to think how people will misuse the system. So in this case, we are also setting what we call account property. See, on the blockchain, another entity that I can set is account property, which is a key value pair associated with my account. So I set the name of the handle as account property. Next time the contract will run and someone will ask to fund the same handle, the contract will reject it. Okay, so let's look a little bit how this magic happens. And I'm really going to follow it. If you really want to try to experiment with it, this is exactly the type of contracts we will develop on our workshop on Wednesday. So you can see that the contract has set up parameters. For example, the Twitter friend handles that it monitors. Okay, this is our Twitter handle accounts. The amount of tokens to reward, all kinds of things. It's activated by transaction. Then typically when you look at blockchain code, of course there is Twitter integration code. When you look at contract code, it's usually composed of many validation checks that you didn't already fund this account. You didn't already use this Twitter handle. And all kind of bad things that people can try to do. So this is very typical. We always use here with JSON objects, and eventually we create two transactions, set account properties that we saw that register this Twitter handle as funded and the actual money transfer. Okay, so this is a less trivial example of how contracts can be used. All right. So let's dissect a little bit what actually happened. What actually happened here? Let's see. Okay. We talked about this, I think. Okay. Right, so I didn't actually show you the contract. So the contract itself is stored on the blockchain. We call it, using a mechanism we call it data cloud. And this is actually the Twitter follower reward contract, okay? You can actually look at it. That's the main class. It's a Java archive. We can even download it and inspect it and so on. How do we know, how can I prove to you that this code is actually this thing that is stored on the blockchain? So what we do, we use, again, since we are Java shop, we use the tools that Java provides. So trivial idea would be to just compile the source code. See that the class file that you got is a class file deployed to the blockchain. But of course this doesn't work all the time, because if you compile using a different version of Java, or you compile with debug information, you get different class files. So what we do first is we run a Java P. Java P is a simple parser of Java classes on the code deployed to the blockchain to check. Then from the output of Java P, we deduce which version of Java was used to compile this contract, and if there is debug information or not. Then we use this information as parameters to Javac, which compiles the class using the similar mechanism, and then we expect it to be byte-to-byte compatible. So we expect complete equality, and then you can be sure that the source code was deployed to the blockchain is indeed what you see in the blockchain itself. So so that's one interesting usage of Java for this type of environment. Then another concern, ideally we want to get sort of an app store for contracts. We want software developers to develop contract, deploy them to the blockchain. We want different entities to actually run this contract and provide them as service. But then there is, since we are in blockchain, everything is decentralized and anyone is potentially malicious. We need to protect the contract runner from anything malicious that the contract developer wants to do. Like, for example, run rm-r on the local workstation and destroy it. Or even worse, try to steal tokens and things like that. So what we do, so again, Java comes to the rescue because Java has a very sophisticated security model, sandboxing. So we run the contracts in something that looks intuitively similar to the way browsers run Java applets. Okay, we use the security manager. It's a Java security manager, which is integrated into our custom class loader. We use the standard Java policy file for mapping by default. When you run a contract, it has no permissions at all. You can grant contract permissions based on the account that submitted the contract to the blockchain. Similarly, intuitively similar to the way we used to sign Java applets with these certificates. We can also use the contract hash itself as a principal to the policy file. So this gives us actually 3 levels of permissions for contracts. One is all contracts, which is very little permission. Then contracts submitted by a specific account. Think about it like apps submitted by a specific company, which can have their own out-of-the-box permissions, and some fine-grained permissions, for example, for the Twitter account, so that it can actually access Twitter or something like this. you can give at the contract level. So this way we let someone can develop the Twitter contract, deploy to the blockchain. Someone else can actually run it and be sure that this contract will not do something that it's not intended to do according to the specification. Okay. Another ways we use Java is for passing parameters to contracts. Contracts has three types of parameters. One is, we call it setup parameters. When you deploy a contract to the blockchain, think about our Twitter handle contract. Perhaps another company now wants to use it to incentivize people to use its own Twitter handles and not the Jelurida Twitter handles. So if you look at the contract code itself, you see that there is a parameter, Twitter friend handles, which is a contract setup parameter. It defaults to, you see it's a default method, it defaults to our own Twitter accounts, but you can deploy your own instance of the Twitter contract and change the handles so that it now uses the Twitter handles that you want users to follow instead of the ones that Jelurida wants to follow. And of course you can adjust other things. So this is called the setup parameter. It's a one-time parameter that you deploy with a contract. Then there could be setup parameters that you do. So one thing I didn't tell you is that everything you deploy to the blockchain is public to everybody, because all the nodes that access the blockchain can see all the transactions, okay? You can have encrypted information, but whatever is encrypted cannot be used by anyone that needs to reach consensus or see what you're doing. So for example, encrypted parameters cannot be used by a third party that cannot decrypt them. So typically, because we deal with Twitter, we need some API key and tokens of Twitter to access it, and of course we don't want to deploy it to the blockchain. So the second type of parameters is parameters that are sensitive parameters stored on the workstation running the contracts. So we have a JSON file, we store the parameters. So you see, for example, these are contract runner parameters, like the Twitter consumer key, secret key, and so on. Then we have third type of parameters. It's parameters that you want to pass to the contract when you invoke it. Like, for example, the Twitter handle that I sent, which represent the link between the Twitter handle and the account that we want to phone. This should be this is done per contract invocation. So this is a contract invocation parameter. So what we do, so each contract defines this interface, and the first thing we do when we start the contract, we load these parameters from the blockchain, from whatever is deployed to the blockchain to the local node, and now we can use it as if we have access to this interface, but with the actual parameters in the blockchain according to the dynamic proxy design pattern. Okay, so we saw the parameter injection. Right. If you want to join us on our on a workshop to actually practice the development of these things, you're invited. Since I see that I have a little bit of time, let me show you how we handle the policy file. Just a second. So, for example, for this specific you can see that all contracts, how these things work. So contracts has their own code base. We invented some dummy URL, it's called untrusted contract code. These are the permissions that all the contracts share. They can all access the temporary directory on the workstation and connect to URLs so that they can interface with external systems. This is modifiable by whoever runs the contract. Then the second layer is the signed by token of the policy file. This is a standard Java policy file. This represents the public key of the account running the contract. So now you can give the contract more permissions based on the public key of whoever deployed the contract to the blockchain. Third level is based on the principal. Okay, we implemented our own transaction NXT security transaction principal, which corresponds to the unique identity of a specific contract deployed to the blockchain. Okay, so I think I presented the. So this was the contract framework provided by Jelurida with the Ardor platform. We have around 10 minutes. I mean, I can tell you, you can ask me anything about blockchain, about contracts, about our specific solution, if you like.
Someone has a question to do? Okay.
Hi. Do you have some example of real contracts that are deployed to the system?
Yes. So if you look at our existing wallet, it is full of existing contracts. For example, I now switch to the mainnet. Until now, one thing I didn't mention is that the blockchain mainnet is where actually things happen. Tokens of value are transferred between accounts and so on. But for development, of course, you don't want to develop on the mainnet because you don't want to experiment and maybe lose fonts or expose your keys or so on. So we also have a testnet that you can use for experimentation. That's what I use. Now, looking at mainnet, you can see, for example, what we call a coin exchange. All right? A coin exchange, you can think about it as a sophisticated contract that does an exchange between the various chains running on the Ardor platform. You see, I'm now on the Ignis chain, okay? And looking at all the orders of the Ardor chain. So on one side, I have the sell orders, that it's basically exchanges from Ardor to Ignis. On the other end, I have buy orders, which are exchange offers from Ignis to Ardor. Whenever we have a match, you'll see a trade here. And this is a real system that people are using today as a decentralized exchange. Anyone can participate. There are there is no single entity that manages this trading, and we have, as you can see, we have the AUR is an interesting chain that is what we call pegged to €1. So you know, if you have one AUR token, you know for sure that you can always switch it to one real euro, okay, and vice versa. Getting real euros into tokens is usually simple, but the other way around is a bit more difficult. But we are working with a third party called Ardor Gate, which is actually supports this peg. Then similar tokens are on-chain tokens that, like, for example, we have two types of this. It's called assets and monetary system. These are two types of tokens that instead of trading between chains, you can trade on-chain. Like, you want, I don't know, you want to collect money for a birthday of a colleague and track who paid and who didn't pay. You can issue almost for free a token here and ask anyone to submit their payment in this token. We have a voting system, which is kind of a demo system to, let me try to show you. Okay, you see, this is just a toy poll that people, you can define a poll, you define what the questions are, and deploy it to the blockchain, then you invite users to vote, and they can all vote until a certain block height. At this height, all the votes are counted, and the results are displayed. And we have quite a few other kind of smart contracts already built into the platform. The lightweight contract I showed you is kind of layer above it that allows you to do more interesting things with the existing applications that are already running on the blockchain. Our business model is, one of our business models is to create more of these chains that are companies that need a blockchain for their own use case, but don't want to deploy a full blockchain on their own. They can rely on our blockchain infrastructure for this purpose. More questions? Okay, you want to see something cool? I have 6 minutes, so if you want. Okay, so let me show you something that I really like. Let's say that you, as I told you, one of the big problems that we have when we create a new account is that you generate this passphrase. If you lose it, you lose access to your funds. If someone reveals it, they can steal your funds. So can we somehow split this into several chunks? Okay, you know what? Let's instead of this, let's use the account that we already funded in the previous demo. Yeah. So let's. No, so I'm going to log in. We have several ways to log in. I'm logging in with my testnet user to the mainnet. Doesn't work very well. So okay, here I'm logged in. Okay. Wait a second. Let's log in again from here on the testnet with remember this one. Okay. Okay. Now we can create something very common in the blockchain world is what is called a paper wallet. Paper wallet essentially, metaphorically said, okay, I don't want to expose my private key, so I will print it on a wallet, on a paper, tear the paper into several pieces, bury some of them in the ground, and whenever I want it, I will get it out of it. Of course, this is not practical, but what if we could split our secret into 3 pieces that only 2 are required in order to sign a transaction, okay? So here I'm saying that I want to split my secret to 3 pieces that only 2 are required. So, okay, and it does it for me. You see, now this is original secret seed, this is a public account, and here I see 3 pieces. Now I can put one of these pieces in a safe in the bank, One of them I can keep in some password manager, and another one can stay in the browser cache if I want to, or something like this. Now, when I want to submit a transaction, let's say that I want to send Ignis back to the contract or something like this. So I'm going to send tokens. Wait, I need to log out again and log in with my account ID, which is this guy. Okay, I think it's this one. So I'm going to send to someone lucky. I'm going to send some tokens. And now I need to sign the transaction with my passphrase, but I don't want to expose this passphrase, okay? So instead, I'm telling it I'm going to use a shared secret. So now I'm taking, let's choose piece 1. And let's choose piece number 3. Combine them, okay. And now I reproduced my passphrase, and it's calculating the fee, and I can submit my transaction. So any one of these pieces is not enough to reproduce a passphrase. Any two of them are good enough. Okay, so this is, for example, one way to increase the security of your account. And another way is what is called a hardware wallet. That is kind of a USB key that you can stick into any computer, even infected with viruses, and use it to sign transactions. Okay, I think that's all I had. I hope I gave you a glimpse of what blockchain is about, and you are welcome to join our workshop on Wednesday. We are at stand number 18. When you head out, you can vote in the tablet over there.